Hello everyone, myself Abhishek PS from AML department, GMU C section. Meet my teammates Vaibhav GP, Karthik SK, and Akash GP. So our topic is linear regression and decision tree for house prediction. So my part, I will explain the necessary libraries in this. So here in important necessary libraries, import NumPy used for numerical operations and handling large data sets efficiently. Helps in performing mathematical operations on arrays. Pandas as in pandas as PD. Pandas used for data manipulation and analysis helps store and process the data set in a data frame that is in tabular format. Next is matplotlib. Matplotlib pyplot used to create graphs and visualizations, help plot scatter plots, bar charts, and comparison graphs. Next is sklearn. Sklearn is fetch California housing, loads the California housing dataset, train test splits data into training and testing. Linear regression implements linear regression. Decision tree regression is implements the decision tree regression. Next, the step 2. 9 data is fetch California housing. Loading the dataset. Fetch California housing loads the real world house price data from California. Convert the dataset to a data frame. PD dot PD data frame. Data column feature names. Converts it into the structured table. Add the target column price. Data target contains house prices but in 1000 units, 1 lakh units. Sorry, it's not 1000, it's 1 lakh units. Multiplying 1 lakh gives the house price in USD. Just step 3. Select the relevant features and target. Feature selection. Instead of using all 8 features, we choose 5. A rooms, average uh, average number of rooms in a house. Latitude and longitude determines house location with which affects the pricing. Population, number of people living in the area. And the median income of residents in that region is done by median. Target variable y. We use price which contains house prices in USD. Further step 4 is will be explained by our friend, my teammate Akash GP.
Thank you, Obi. Step number 4, splitting the data into training and testing set. Mainly, training set 80% are used to train the model, and remaining 20% are used to evaluate model performance. Then, random set is equals to 40 to ensure that split is consistency every time. Step number 5, train a linear regression model. How does linear regression work? Find a best fit line that predicts that basic price based on futures using the equation as mentioned in the code, and fitting the model. Fit learns the best parameters from the training data. And next will be step 6, training a train a decision tree regression. How to train a decision tree works: split the data into smaller decision tree groups and user if else condition to predict house prices. And next, max depth is equals to 5, limits tree depth to prevent overfitting. The next step is taking user input. What happening in this step is, this step of the code inactively collect input from the user. The user provides details about a house and the program uses the information to predict the house prices. And next will be breakdown of the input. Mainly, first one, in that room, the user enters the average number of the rooms in the house, and next is to ensure that input is in a decimal number. The second will be latitude. The user enters the geographical latitude of the house. The latitude value are typically between 32 to 42 degrees for California. Longitude, The user enter the longitude of the house location. Longitude value range between 124 degree to minus 114 degree. Population represents the population of the neighborhood where house is located. The affect pricing because high population density can impact demand. The next will be income, representing the medium income of people in the area. One of the strongest factor affecting house prices, higher income, higher price. Why do we need user input? We need real world values to make a prediction. The user provides details that matches the features the model was trained on. This makes the prediction dynamically rather than using predefined test data. Next will be continued by Vaibhav.
Thank you, Akash. In next step, we are converting the US dollars to INR. Here we are converting the US dollars money to Indian rupees. In line number 51, in line number 50, we are converting the converting the US dollar to Indian rupees. In line number 52, we are converts the linear regression model predicted price to INR. In line number 53, we are converting the decision trees model predicted price to INR. Uh, why this is important means since our model predicts price in US dollars, but we need the price in INR. We multiply by 83 approximately to get the price in Indian rupees. Um, Next step, we will display the predicted prices in printf predicted house prices. We will display as a heading. In next step, uh, linear regression model, we will format the price with commas and two decimal places. In decision tree model code, we will we will show the does the same for the decision tree model also. In next step, we will evaluate the model performance. Uh, because of the linear regression model makes predictions on the test data, that is X test example. The decision tree model also makes predictions on the same test data. Because why we need this means we need to test how well our model perform on unseen data before using them for real world predictions. In next step, we will measure the MSE for linear regression. In next step, we will measure the MAE for linear regression, and same for decision tree also. Measures MSC for decision tree and MAE for decision tree also. MSC means mean squared error, measures the average squared difference between actual and predicted prices. Which one is lower is very better. MAE means mean absolute error. It measures the average absolute difference between actual and predicted prices. Here also lower price is very much better. In next step, we will print the model evaluation results. Here we print the error value for both models in the readable format. Um, it is very important because the model with the lower MSC and MAE, that means that are mean squared value and mean absolute error, that are more accurate. If decision tree has higher error, it may be overfitting the data. In next step, we will show the plot actual versus predicted prices. That means the regular prices versus predicted prices. Uh, in plot figure, figure size 15,5 means that we will create a large figure. In next step, we will prepare for a side by side subplot also by using linear regression. In next step, we will plot predicted value as blue dots. Further steps, draws a red line representing the ideal case where predicted is actual. Next, the labels and legend are added for clarity. These steps are important because if points are closer to the red line, the model is accurate, very much accurate. If points are scattered far away, the model is inaccurate. This means the model is we will draw the model in the form of graph. Uh, Thank you.
Thank you, Vaibhav. Next, I will continue. In the next, we have the plot for linear regression and plot for decision tree, where this create a subplot within a figure. It specify that will be the second plot in a one row, two column layout. The first number one represents the number of rows, and in second two represents the number of columns, and third one represents two, indicate this is the second plot in the layout. These two are same, and we take input the subplots as 1 comma 2 comma 1 comma 2 comma 2. Next, where the Python X level, it is the actual price predicts, and it it gives the output in the inner, and it predicts the house prices, and it prints the actual price versus prediction prices. And next, in the decision tree also, PLT scatter, it creates a scatter plot, which is in upper plot we mentioned 1 comma 2 comma 1 and 1 comma 2 comma 2, where y test dot ust to inner, this actually converts the house prices to inner, and prediction dot ust to inner, where house price using the decision tree model, it also converts to inner, and where the alpha is equal to 0.5, which makes the point slightly transparent, and color is equal to green, which is the color of the points to indicate the points. And next is the label predictions, adds a label for the legend indicating this are the predicted prices. And next is the plot y test plot dot plotty, and this line explains the create a line plot, and y test dot ust, this the actual prices in the both the x-axis and y-axis. This forms a straight diagonal line y is equal to h, which represents perfect predictions, and the line is red because it indicates the difference of the scattered points on the points on the line, and where the scattered points indicates the prices which are predicted, and on the points which are on the red line indicates the actual prices. And plot dot x label sets the x-axis label and set the y-axis label by y plot dot. And the plot dot title sets the title of the plot, and plot dot legend displays the legend to differentiate between the predictions and the actual prices. Next is the plot dot tight layout and the plot dot show, where the tight layouts adjust the spacing to prevent the overlapping elements in the figure, and the plot dot shows displays the final point. And next is the plot user input prediction comparison in inner, which creates a new figure with a size of 6 inches wide and 4 inches tall, where next model, the linear regression decision tree and prices is equal to LR price inner, which a list of model names, and the prices are least predicted house prices in the inner from both models. And next is the plot dot bar, which creates a bar chart where the x-axis as a linear regression and decision tree, and y-axis represents the predicted house in inner, where color is equal to blue comma green. These bars are colored blue for linear regression and green for a decision tree, where bar graph is represented. And next is the plot dot y label, labels the y-axis as the predicted price inner, sets the title of the charts, and plot dot show displays the bar chart. Next is a summary. The first plot compares the actual price versus predicted price for the decision tree model, and second plot compares the predicted price from the linear regression and the decision tree for a user input. Here is our code, and next take we will output, and we will take the room numbers of 5, and latitude of assumption 118, and longitude of 101, and the population of the area we will take 5,000, and average income of the resident we will take 7.5, and here we run the code, and it gives two graphs. First one is the linear regression, which is the prediction versus actual, and in the decision also prediction versus actual, where in the linear regression the points which are almost nearer to the red line, this indicates the prediction of the linear regression, where the points almost are nearer to the red line, which means the prediction of the actual price and the prediction price was nearer, and it is good. And in a decision tree where the points are scattered and the dots are scattered, and the less number of points are in the line of the red line, where it indicates the less or prediction of actual and versus prediction prices were less efficient. And yeah, this also gives us a graphs where the predict the linear regression and decision tree. This also shows the how the linear regression model gives the output and the decision tree. Here we compare the outputs where the linear regression gives the amount of this much, and decision tree model this much, where the linear regression model gives the number and MSC, and MAE we compare with the linear regression and decision tree, where the linear regression gives the less number of MSC and MAE, where we conclude that the linear regression gives the more actual output of predicted prices and the predicted price versus actual price. And this model, linear regression models, works very well in our output, and this shows that the prediction of linear regression is very good for us predicting price. And we conclude this by our video.